Welcome to a lesson with Dr. Powell. Let's look at an example of a commutative diagram and what it is. First of all, when we write down a function and we're considering what its domain and codomain is, we can use this notation. And then we can give it a function definition here, what we do with input, and go out to 9x. But instead of putting f right there, let's put it on top of the arrow. All right. And the advantage of this is that we can use the same diagram and build off of it to have other functions, to talk about other functions with their domain and codomain, maybe something that shares the same domain. So for instance, we could put an h here where h of x is equal to 12x. And we can keep on building where this is the domain. In fact, we can even reuse things. Like we could put an h here, and the same definition with domain r and going to codomain r, say, and if we want, we can even put another function here, g. We could say it's g of x is equal to 16x. Now, right now, this is a composition diagram. Why is it composition diagram? Well, composition means that you run one function then another one. So like you input something here, you put it into this function, then you take that result and put it through here. So going along here, the path from here to here is a composition. It's like g of f. So run f and then run g, going this way. And going this way, it's like h composed with itself, like h of h, going this way. Okay, so this is a composition diagram because we have paths, arrow paths, and those are compositions. Now, what makes a diagram commutative? That is, if we start somewhere and we end somewhere, every path that takes us from here to here should produce the same result. How do we check that? By looking at individual elements. We can write an arbitrary individual element as an x and just see where it goes using an assignment arrow. Using function h, we get 12x. Use h again. So we multiply that result by 12, we get 144x. Okay, going this way, what happens? Well, here we have 9x, and then running g, we multiply that by 16, and that results 9x by 16, and we end up getting 144x. Notice how these results are the same. This diagram is commutative. These are the only two points that have multiple paths between them, and it checks out. And so therefore, this diagram is commutative. Thanks for watching.